Ladies and gentlemen, we are here for another glorious edition of Ask That, and today we're going to get a little scientific. We're going to talk about data, and we're going to do that with none other than Douglas Starnes. Douglas, how are you, sir?
Fine, Clark. How are you?
I'm doing fantastic, although it snowed here last night, so that's a disaster. I know it didn't snow where you are. I'm a little jealous. Oh, no, we froze. There we go.
No, we're good again. It was momentary. Well, actually, I'm in Memphis, and we have a freeze warning for tonight, so which is very unusual for this time of year, so the stupid groundhog was right for a change.
Well,
Knew more about what he was talking about than we thought.
I'm glad that we could give you a little bit of that northernly cold air to depart on your to your wonderful spring. Before we start talking, let's give everybody a quick introduction. Why don't you tell everybody who you are and what you got going on?
So I live outside of Memphis, Tennessee, and I've been developing software for close to a decade in some form or another. Worked in both academia and industry. Primarily, I have been I've come to be known as a Python guy, and I'm pushing that more towards the data science machine learning field. Right now what I'm doing mostly is I'm working on authoring video courses and training for software developers, mainly through Pluralsight right now. I've got several courses out and working on some other interesting things with them. And that's other than that, I speak at conferences quite a bit. I'll be at CodeStock week after next. I'll be at CodeStock I think it's the fourth time I'll be there. So, and then I help run the Python User Group here in Memphis. Also help out with the .NET group here in Memphis. So dogs and cats can get along.
Oh, that's funny. So today we're going to talk about data science and machine learning and kind of see where that takes us. Let's start with just what does data science even, let's put a definition on it. What does that mean to somebody?
Well, the way that I always describe this when I do my Data Science 101 talk is I always say data science is something that you can ask 10 different data scientists what they do and get 20 different answers at least. It's multidisciplinary. And hang on just a second, the garage door. I didn't think about that. My office is over the garage.
Oh, that's awesome. Hey, this is what we do, man. This is real world. We bring it right into people's homes.
Yeah. So it's going to go down here in just a second because I think somebody's leaving. But at any rate, data science, like I said, it's multidisciplinary. It's obviously has to do with data, but it's different things. So there's a lot of math, a lot of statistics involved. Although if you're involved with we're using some of the platforms, especially the Python platforms, you don't really have to know a lot about the mathy part of it. You just have to know some basic definitions. It's not necessary. A lot of people think sometimes it's big data. Yes, it's often associated with big data, and yes, again, you need to know about big data, but you don't have to be like a DBA or anything. You just basically kind of have to know your options. And data science itself is not specifically big data, just like computer science is not necessarily a science or doesn't even necessarily have anything to do with computers. It's kind of marketing in that way. But there are also other things that you might not think of necessarily associated with because data science itself sounds like a very technically oriented field, and while it is, there are also a lot of other things that come into play. So there's actually an artistic component in some ways because with data, if you're trying to tell a story to somebody to a manager or C-level executive or something, you're not going to want to show them a great big table full of numbers. They're going to want to see something they can summarize easily. So visualizations are very, very important. And when you get to visualizations, you get to aesthetics. So you might want to know something about how colors work together. I mean, you don't have to be a graphic designer and a Photoshop guru, but you don't want to have something that has the equivalent of pink with purple polka dots. Excuse me. So things like that. Uh, Sometimes domain knowledge can be a good thing, depending on what you're doing. Just the ability, obviously the ability to communicate. Like I said, it's multidisciplinary, and yes, you do need to be able to write some code, but you don't have to be a computer scientist. I mean,
So
yeah, a computer scientist, yeah.
sure, sure. So who then is this really for? I mean, let's everybody has data to some regard, unless you have some really simple static website. Chances are you have some data store somewhere that's got a whole bunch of stuff in it. So when we talk about data science, does this apply to everybody? Should everybody be thinking about, hey, do they even need to have a scientist, or is, where does this, like, for people who aren't in this, should they be paying attention? Should they not be paying attention?
Well, it's going to, of course, the cliche data is eating the world. So you're going to touch it every day. Everybody has one of these things.
Yep.
And, and has been well publicized whenever they're walking around with one of those things, they're generating data constantly.
Yep.
So you need to be at least aware, I would say, of the influence that it's going to have. But I mean, I've seen, so I mean, I hate to use the answer, it depends, but I mean, I've seen books and talks and things that are titled Machine Learning for Graphic Designers. I mean, I seriously saw that one time. And it's not necessarily about, okay, a graphic designer needs to know how to, needs to know what the algorithm for doing Bayesian analysis is or something like that. But they need to know, okay, here's what to expect, more or less. Okay. Here's what to expect. Here's what's going to be coming at you. And also, if you need to get more information from somebody else, here's what you need to know in order to ask the right kinds of questions. So now, of course, if you're a development manager and you're managing a team and you're developing a dashboard that compiles sensor data, well, then obviously what you're going to need to know, you're going to need to have much more in-depth understanding. So this is something that could literally touch everybody. Sure. When I saw, I think it was called Machine Learning for Graphic Designers. And I thought, wow, that's, I really hadn't thought about it, but yes, that does make sense.
So data science is much bigger than just machine learning, correct?
Well, so here's how I characterize it. So you have artificial intelligence, okay, which is this dream that's been around for a long time about basically being able to not necessarily reproduce human intelligence, but be able to mimic it, be able to get the same results. Mm-hmm. Then you have machine learning, which is a subfield inside of that. And then inside of that, in the past few years, we've had deep learning, which is basically neural networks. Then you have data science. Data science is not necessarily a part of artificial intelligence or machine learning, but it's definitely related. So I wish I had my slide up here. I can show you the slide, but it's tangential. It's a tangent to that field. So there are a lot of libraries such as NumPy, Pandas that you'll use in both Matplotlib, the visualization library that you'll use across both. I'm talking about the PyData stack here. In R, there are other libraries, and Java has its own. So they're definitely related, but machine learning is not strictly a part of data science, but like I said, they are related, and you're going to use many libraries that cross between the two. Okay.
And so let's make it concrete for folks, because I while people are listening and watching, I mean, I think it's good to paint a scenario around it. So if I don't know, if we're at that conference and we've got a big data store of, I don't know, people's favorites and I don't know, the sessions that they've gone to or whatever. Mm-hmm. Like, where does data science kind of fall into that, and in relation to machine learning too? Like, what are we trying to solve? What are we trying to get at?
Well, with machine learning, so you've got you said the favorites. That brings up kind of a classic example. The Amazon example, recommendation engine.
Yep.
That's something. So something in there, some kind of clustering algorithm or something like that you would use to be able to say, okay, these people, the people with these characteristics seem to be gravitating towards this type of talk. Okay, when somebody else when we discover somebody else that has these same characteristics, we can recommend the talks that fall into this category for them.
Interesting. Yep. Okay.
Data science is machine learning is more on the predictive side, whereas data science is going to be more on the analytical side. We're going to say, okay, we have a whole bunch of we have a whole bunch of preferences. What talks did people prefer, so that we can know in the future what talks that we should seek. Because this is our trying to more or less come up with the demographics of your audience, I guess,
Okay.
of your target audience.
Fair to say one's certainly more targeted at I was going to say the pre versus post.
Yes,
but I'm guessing you could use machine learning in the post as well.
Yeah, like I said, machine learning is. It is more predictive. Sometimes it's actually called predictive analytics. In fact, Azure used to call their, I don't know if they do anymore, but because they've changed it so much. But Azure machine learning, they used to say it's a predictive engine.
Okay.
Machine learning generally goes around making a prediction, whereas data science goes around more or less analyzing what already exists. Although, again, there's crossover between the two.
Right, totally. And so then the output of, say, what you mentioned, to rattle off a number of libraries that fit into the data science space, is the output only ever reporting based stuff, or can we do more? Like, is the output stuff that people need to read and react to, or can we be more programmatic with it as well?
Well, no. Are you talking about more real-time interactive systems?
You were talking earlier about being able to do analysis on the data and having some reporting around. So that assumes that some human is going to be involved and is going to make some super awesome decision based upon what their data science scientists said.
Okay.
And I think of like a very collegiate, like, hey, I had this huge data set, and so we wrote a bunch of code and we figured out, and then it started giving us analysis, and then human then do something with it. Can we flip that on its side and say, hey, I did a bunch of cool code and analyzed a bunch of data, and now machines went and did other things based upon that data?
No, definitely. No. You can automate, so to speak, pretty much all this. And in fact, that's kind of what machine learning does. And then also you have the idea of intelligent agents, agents which can react to a human being, or agents which can react to one another. I actually, when I worked for the university, that's actually, we were working on agents that spoke to humans, but we were also working on ways that agents could feed off of each other. No, it's definitely something that you can take and sort of remove humans from the at least the more mundane parts of it.
Sure. What kind of skills are we talking about having? I mean, what does it take to start getting involved in this space? Because I think that the term, anytime scientist, I mean, I know you said earlier like computer science, and you're not necessarily a scientist, but I think it's it feels very scary to get involved when we're analyzing things.
So I do a talk called Deep Learning with Python and Friends that I'll actually be doing at Codestock, that I used to call TensorFlow for folks without or with a PhD. And the whole point of this is that you hear TensorFlow, neural networks, deep learning, and it's done by the Google Brain team.
Right.
You hear all that, and yes, it sounds very, very intimidating. But the whole point of the talk is this stuff is not that difficult. And its libraries like TensorFlow, and even more so Keras, that that make this possible. So I think the number one thing is that this doesn't have to be intimidating. You do not have to have a PhD in math. I've worked for people who have PhDs in math,
yeah.
and they think well above the level of what you need to do to understand this. I worked for a statistician at the university, and it's you have interesting and I know other people who have PhDs in math, and you have interesting conversations with them that go well beyond this. So that's the main thing, is it's not as intimidating as the name might sound. And data science, I guess in some ways you could say even more, because data science, everybody, love it or hate it. They've looked at Excel. I mean, one of the thI always say is Excel is not a 4-letter word. It's actually a great tool. Its only fault is that it's remarkably tolerant to abuse. But I mean, everybody's seen Excel. And so, with the very basic levels of data science, you're doing a lot of the same things. It's basic statistics. You're doing the, just fundamental descriptive statistics on these things. Then you can get into other things that are more deeper. But taking something like pandas, which is somewhat like the equivalent of R's data frames, but for Python, it's just learning to think about it a different way. I'm trying to decide if I can actually explain this in words or not. But pandas basically pandas is basically just data manipulation. There's not really a whole lot, or the fundamentals at least, are just data manipulation and trying to massage the data into a form that you can work with to get the results. And then generally what you're going to do with that is you're going to push in something like matplotlib, which is a visualization library, which is then going to go to the people who actually make the decisions. That's another thing that I about this whole field that's really, really interesting, is that I don't know if you're familiar with Joseph Soros. He's a vice president at Microsoft in charge of the AI division or something.
No.
This guy, I saw him I believe he did it at Build a couple of years ago, and he said this at the end of his talk, and he said there's 3 points that you need to remember, and this has stuck with me, and every time I do my data science talk, I always mention these. He says data is worthless, analytics are worth pennies, but decisions are worth dollars. And that's the other thing that you really have to keep in mind with this is, okay, yeah, you got a lot of cool algorithms out there, but again, 80% of this is actually cleaning up your data, getting it into a format that you can use. That's where something like pandas would come in. And a majority of the rest of it is getting it to somebody who can actually make a decision with it. Sure. Because, look at Amazon. They put their entire product catalog out on the internet, or an API out there. It's public. I mean, all you have to do is tell them, hey, I'm going to use it, so they can track usage. Amazon, arguably, probably inarguably, has probably the largest single product catalog out there.
Yeah.
But keeping that proprietary, keeping that inside. First of all, people are going to scrape it anyway. But keeping that proprietary. But they're making it easy. They're actually enabling this. Yeah. Just having all that data, would keeping it proprietary give Amazon a strategic advantage? No, it wouldn't. Right. But do they go through and do they give you their machine learning algorithms for creating recommendations? No, they keep that close to the chest because because that enables people to make decisions whether or not to buy their products. Sure. So that and the same thing goes with other places too. That's why open data is becoming so popular, because here's the thing. Now Amazon, somebody might do something with Amazon's data, and Amazon look at that and say, hey, we could. Maybe we can piggyback off of this. So that's, I don't know. I think I may have gotten off topic there a little bit, but I mean, you talk about how do people get started? I mean, that's the main thing, is that, realize that it's not as intimidating as it might sound. Yes, there is a 4-letter word involved, math. The math is not that traumatic. It's not that arduous. The other thing is that you have to remember is that a lot of the times, once you learn a lot of the really cool algorithms and things, they've been done already. That's one reason that Keras opposed to TensorFlow. Keras is basically a wrapper around TensorFlow that takes all of the deep learning concepts that you can do in TensorFlow, but puts them in a much more prepackaged format. So it's a much more so what you end up. My point with all this is that whether you're using Keras or Pandas or something like that, what you're doing is at the end of the day, you say, I have a situation, and I have a whole bunch of tools over here that I can use. Just match them up.
Yeah,
that's actually at the end of the day what you end up doing. The rare instances that you are working on something completely new, yeah, you may need a PhD to do that or hire one. Sure. But that's the main thing is that if you have to learn how to speak the language of data science and machine learning, and those concepts again are not that intimidating.
Yeah. Hindsight's always 20/20, right? When we're doing something and we kind of look back, what are some common pitfalls or misconceptions that people have when they start getting into data science and machine learning?
Well, first of all, I'll go back to the thing that it's much harder than it should be, and people often make it much harder than it should be. Some of that's the fault of the literature, especially on the machine learning side. Because they'll go through and you'll pick up a book and they'll start off with 3 chapters of math. Yeah. When you don't need that at all. Another one is that it's sort of a it's a cure-all. It's not. Actually, one of the big I'll get to the other, but that it's a cure-all. Like I said, it's multidisciplinary. Again, you have to, again, going back to that machine learning for graphic designers, who would have ever thought that art would be a part of something called data science? Yeah. The other one is, and this one applies more to machine learning, is that, first of all, machine learning is not perfect. Of course, none of this is perfect, but machine learning, you hear machine learning, especially neural networks, and people think, ooh, we're taking how the brain works and we're telling a computer to do it.
Yeah.
No.
Yeah, it sounds like the world's going to be taken over by robots.
The term neural network is marketing fluff. It is literally. What I always say is that neural networks are loosely inspired by how neuroscientists believe the brain might possibly work today if they're on the right track. Again, we're not trying to reproduce the processes of the brain, but again, we're trying to mimic the outcome is what we're trying to do. Yeah. And if you think about it, in some ways, especially when you're training a machine learning algorithm or a neural network, in the very beginnings, it's guessing, and then as you get through training to the end of the model, the guesses just get better. In some ways is what it is. And the reason I say all this stuff again is to get back to the point of it's not as intimidating as what it should be. But yeah, that's another misconception, is that machine learning, or that, like I said, especially neural networks, is that it's based on it's based on something that really is related to biological functions, and it's not.
Yeah. How much data, or how big of a data graph do you need for all of this to really be useful? Is there a point where you just don't have enough, and it's like there's a whole lot of like ramp up, and it's like I could have just done that anyways, like it's just overkill?
Well, okay, let me try to put this into perspective. So there's a data set out there it's a very popular data set called MNIST. And what it is it's these little, they took little scans of handwritten digits, and there's like 60,000 of them in the training data set. That is considered to be a toy data set. 60,000 samples is considered to be a toy. Okay. You can have billions of samples sometimes. If you get up to the level where Microsoft's Vision service, where you feed it an image, and you just send it an image, and it sends back and says, hey, and it gives you a caption. And I've seen some live demonstrations that were quite humorous, but generally it gets you a very it's generally very accurate. It can say this is a dog catching a frisbee in a park or something like that. It can actually get that accurate. For that, you have to have billions of examples, and it takes weeks or months or something like that. I mean, insane. I remember we were working at the university. We were working with data sets on the order of hundreds of millions. I mean, I wasn't doing this part of it, but I mean, I was aware of what was going on. But they were doing hundreds of million, and what they were having to do is they were taking days on a supercomputer to actually crunch these models. And so, how much data does it take? Well, again, it depends, but the general answer, but generally the more data, the better. Now, yeah, you can definitely get to a point where you'll get diminishing returns, on having more data. So eventually, yeah, you've got to say it's close enough. But, again, that's one of those things you get to feel it out in a way.
Yeah. I mean, I love the 3 points earlier, from the guy at Microsoft, which is, in the end, it's about making decisions, right? The decisions are the valuable piece. So the amount of data is kind of, I don't know, maybe I shouldn't say it's irrelevant, but if the decisions that come from the amount of data help you make that decision, then it doesn't matter if it's a million records or a billion records. It got you there a little bit faster.
Right. And that's one of the things about this is an iterative process. You go through, you train a model, you see if it gives you what you want, and then and then after that you've got many options. Do you need a different algorithm? Do you need to clean your data? Do you need more data?
Yeah.
That's
all right. So you just mentioned your model and cleaning the data. Let's say I have millions and millions of records, but my data set's 15 years old, and somebody decided to use really obtruse naming and all that kind of stuff. Do I need to take it through some kind of process? I mean, there seems like there's a bit of work there to take the obtruse data model and tell the robots that this is what this really means.
Well, now we're in the realm of machine learning, not necessarily data science, although some of this does apply to data science as well. But when I do machine learning, when I introduce people to machine learning, I go through 7 steps, and these are roughly more or less. I actually stole these from Microsoft in some way, but it was a chart that they did about Azure machine learning, because Azure machine learning was actually how I got into machine learning.
Okay.
But so, see if I can pull them up from memory. It's acquire, clean, split, train, test, score, and evaluate. And that second one right there, clean, is what you're talking about.
Okay.
And that one, I think I said earlier, you can spend up to 80% of your time cleaning your data, because of course garbage in, garbage out.
Yeah.
So and some of the things that you said, naming it can be something as mundane as column names, naming conventions.
Right.
Looking for missing values is another one. So, especially with sensor data, you have a sensor dropout. Okay. So you've got all these observations here, and you've got this one. What do you do? Do you use a default value? Do you take an average? Do you dismiss that observation completely?
Yeah.
Other thing, computed columns. So like you have you have monthly temperature data for something, and you want but you also want to include yearly. So you would have to compute that from the others. It's of course, and now that's one that actually does go across, and it goes outside of data science and machine learning, database administrators, normalization, normalization of data and that kind of thing. So just that cleaning step, that's what you're talking about. And yes, that is a huge part of it. It's probably the most boring part of it, unfortunately. Right. But, maybe outside of acquiring, but it is the one in which you can likely spend the most time. It's probably worthy of, a full day workshop on its own. Yeah. But also that's where library, that's where like the PyData stack, which includes the aforementioned NumPy and Pandas, they have libraries that make this much less painful.
What about disparate data sets? I mean, we're in this world where we have lots of options for databases, time series, NoSQL, relational, like it goes on and on. Do I end up having to like get all of my data into some common set? Or can I try to stitch together these different data sets, data stores, which could be semantically different, right? You mentioned the sensor data, but maybe that sensor data kind of is a dumping ground in a NoSQL database, but yet, there's a whole bunch of information in another data store that gets back to customers and what I'm just making stuff up at this point. But
yeah.
But is there some effort to like bring this all together in the warehouse or the lake or the pond that, I can go put the robots on?
Well, eventually, yeah, you're gonna it's gonna work best if you have a common data source. How you get there is not really the concern of data science or machine learning.
Okay.
That's where like where I said before, big data, yeah, it's related, but you have to be a DBA.
Sure.
No, you don't. Now I will say one thing. When you the situation that you just mentioned brings to mind Cosmos DB in a way, where it's not necessarily. I would love to see what the underlying physical data store for Cosmos DB looks like. But where you have that. You have multiple APIs. I think what is it they call it? A multi-paradigm database, I believe is what they call it, or I forget I forget what the exact marketing term is. But where you are able to take, not necessarily different. You could you could use it to take different data sources, but they do it from the perspective of APIs. But so something like that, yeah. But again, that's more into the realm of more information. I don't know what it would be, but that's something that kind of fall outside of the realm of data science because it does more. It's more of an administrative thing.
Yeah, I'm just thinking about the many of enterprise places that I've worked that has this section of the business that does this thing and it's in this damn data store, and this section of the business that does this thing, and you have the classic scenario of like I don't know what my customer looks like because they are a financial based customer and they're also in auto, and so the two worlds don't align, and then yet we want to really make a decision, and to do that we've got to like bring these two worlds together and look at one's history, and yet you have systems that have been around 10, 15, 20 years, so like it's not feasible to say we're going to take those millions of records and just like put them somewhere else.
Right. Well, so for example, there are ways to get. Here's something that's kind of related also. So you have R and Python, and historically these two areas have had kind of a mutual disrespect for each other. In a way, but again, dogs and cats can get along. So you've had ways to. I have not done any of this in a while. I really need to brush up on R, but I believe it was called R to Pi. It may have been Pi to R. However, there are libraries that allow you to talk between them to access R code from Python or vice versa. There's a company called Anaconda. It used to be called Continuum Analytics in Austin, Texas. One of the creators of NumPy is one of the co-founders. And but at any rate, they recently announced something where they actually have their distribution actually supports both. And they had some big announcement. I think it was them that had some big announcement recently that they were making it easier to work between R and Python. So yeah, so yes, it's the problem is obvious. People are very, very aware of the problem. It's just that the solutions outside of somebody who's a practitioner of data science, they need to be aware of them, but they're not necessarily. They're more complaining, waiting for the solution, I guess.
Sure. Before I ask my last question, at the end of every one of these shows, I like to extend a bit of gratitude and acknowledge you. And I'd like to just say thank you, not just for being on this and AskStaff, but really being involved in the community and spending the nights and weekends. I know you're putting together some courses for Pluralsight and all of that stuff, and that care and feeding back to the community takes a lot of free time and effort, and for that I just want to say thank you. So then my last question. Go ahead.
No, I was just gonna say, well, I appreciate the compliments and everything, and I do enjoy this. I mean, I really do this because I enjoy it. Otherwise, the nights but you talk about the nights and weekends and things. It's not. It's not completely altruistic. I mean,
Oh, yeah.
I mean, sometimes I say because, and yes, while I really enjoy going to conferences and things, and yes, it does take time to prepare the talks. Sometimes I say maybe I'm a bit of a narcissist, but also, I do this, I go because I'm marketing my brand and everything. So, yeah, but no, I do this because I enjoy it, and I enjoy talking to people like you, and, I do it as much as time. I do it as much as time, as much as time permits. So yeah. But no, I appreciate it, and I was happy to do this morning.
Absolutely. And so then my last question is, given that you're deep in the weeds in all this, we will certainly include some references in the notes below, what would be your Douglas piece of advice for people who want to get started or learn more or whatever?
Well, as far as machine learning goes, there's some slides that are put together by people at Google, and I'll ship you the links to those. And they're and what they are is some places what it is these started out being brain dumps basically. In fact, one of them I believe actually is some kind of a designer at Google. But at any rate, and they started out being brain dumps, and they just got more and more. I mean, these are like 3-digit slides. They're the size. So hundreds of slides, but what it is, it gives you kind of an overview of the concepts, and that's obviously the first thing is you need to understand the concepts. There was, I'll use a golf analogy. You're a golfer, aren't you?
Yeah.
If I remember correctly. Okay. If I remember, I thought I'd remember because we've talked in the past at some point.
Yeah,
and I thought I remembered you saying you were a golfer. So, it was Nicklaus actually who said this. He said, after the winter's over, what do you want to do more than anything when the golf season starts? You want to get out there. You want to play golf. You want to get on the course. He said, don't go out there and hit a bunch of balls at the driving range trying to get your technique back, because you haven't played for 4 or 5 months, depending on what part of the country you are. So, and that's what I look at this, when you say how to get started, don't go through and say, I have to understand the map. I have to know, I have to understand this library, the API for this library in great detail. No, go out there, learn about the concepts, see what can be done with it, get excited about it again. That's why you go out and you play and you play around. You get excited about golf again. If you go out there and just hit balls, it's like, oh, great, that one went to the left, that one went to the right, great, I'm not going to. You're going to get frustrated with it. So that's the main thing is get excited about it. And then after that, this is everywhere. So obviously conferences are a great way. Pluralsight has a lot of great references, including mine, that are out there. There are a number of good people to follow on Twitter. I can provide some links out there. But also if you look at, Google is constantly doing, Google's one that's doing a lot of this, is they're constantly putting out little snippets on YouTube about their products and machine learning. There's also a number of good people on YouTube. There's one, I'm not going to try to pronounce his name because I'll massacre it, but I'll send it to you as well. And he's very popular putting this into. But what he does is he does like little 10-minute videos. So it's something you can consume, something you can consume on a coffee break or something.
Sure.
So there's all kinds of stuff, and like I said, I'll ship you. We'll sync all this stuff afterwards. Yeah.
With that, how can people find out more about you? What you got going on?
Well, my Twitter, which is powered by AltNet, and I'll send that to you. I'm also I try to be I have a blog, but I need to get into that more. But also I'll hopefully be at a conference near you. Hopefully I'll be at a conference near you in August, I believe it is. And whenever I go to one of these, I try to stay for the entire time. I try to make myself as available as possible. And so like if you have an open space, it's like if people have open spaces, I try to hang out there. But I do try to get to people on Twitter. People, check out my Pluralsight courses and find me there. That's another way. Outside, I'm on several Slack channels but they're generally locally related.
Sure.
But
so you're out and about. So you're out and about. You're out and about.
Yeah, I'm around, but generally Twitter is going to be the best way to find out to find me. Yeah.
Okay. Well, with that being said, folks, thank you for joining us. If you're interested or you're doing anything with machine learning, data science, AI, leave some comments below. Tell us what libraries work for you. Maybe share some of your hurdles and your thoughts on the subject. Give us a thumbs up, share it with your friends, and we'll talk to you next time. Douglas, thank you for joining us today, and I look forward to diving into some of this. I've got a lot of ideas rolling around on where we can take some of that conference stuff, and I am no mathematician or scientist, so
neither am I.
I'll be asking questions.
I have a bachelor's degree in music.
Oh, see,
that is my formal education. Is I have a bachelor's degree in music. So
there you go.
So if I can do this, anybody can.
God bless. Well, and on that note, thank you, everybody. We'll see you next time.